We all know that when you have 32-bit PC, we can go up to 4 GB of RAM. So let's take a look at what the actual reason behind this claim. Before moving towards looking at our real problem, let's take a look at how memory is organized in a computer system. So in PCs, memories are arranged in cells, and when I say cell is the smallest possible memory block that we can access. In case of PCs, the smallest possible memory block that we can access, or the size of the cell, is 8-bit. So it's a 1 byte location. You have 8 different bits you can access, and the whole memory is made out of this kind of cells. And then when you have this much of different cells, we need to have a mechanism to access them uniquely. So for that, we put numbers to them. We call them addresses. So we have unique address for each and every cell. So that is the idea of having addresses. In order to do this one, in computing system, we use address bus. Bus is a collection of wires. So the number of wires says number of bits you have in the bus. Now here what I'm show here is 4-bit address bus. When you have 4 bits, uh, we know that each bit can take either 0 or 1. So when you consider that, you can have 2 to the power 4 different combinations. That means 16 different numbers you can have this bus. So if the address bus size is 64-bit, you can have 16 individual numbers, and those numbers starts with 000000001 and so on, and it ends with 1111, which is equal to 15. So the smallest number is 0 and the maximum number is 15. Altogether you have 16 different distinct locations if you have an address bus of 4 bit. So the capacities, so each one is 1 byte. So altogether you have 16 1 byte memory cells you can address by having 16 4-bit data bus. Now suppose we have 32-bit address bus. The system suppose 32-bit address bus. So having 32-bit address bus, we can have 2 to the power 32 different address locations. So having these 2 to the power 32 address locations, we can uh, address these 8-bit memory cells or 1 byte memory cells. We can go with 2 to the power 32 1 byte memory cells. So that if you consider the capacity after having this much of 2 to the power 32 memory cells, it is 2 into 32 into 8 bytes. And if I expand this 32, 2 to the power 32 into 2 to the power 10, 2 to the power 10, 2 to the power 10, and 2 to the power 2, and multiplied by 8 bits, we know that it's a 1 byte. So then you can amalgamate these 2 to the power 2, that is 4 into 1 is 4 bytes. So this is 4 bytes. And then we know that all these 2 to the power 10s are you changing your, so in digital electronic system, in order to get kilos, megas, and gigas, those suffixes we multiply with 2 to the power 10, not 10 to the power 3. So 10 to the power 3 is 1000, 2 to the power 10 is 1024. So therefore, so you get 4 bytes here. Then when you consider this one, 4 bytes, and when you consider this 4 kilobytes, when you consider both of them, uh, it's 4 megabytes. When you consider all three, it's 4 gigabytes. So that is how we get the limitation of 4 gigabytes in the 32-bit system. So if you have experience with 32-bit system, if you even plug 4 gigabyte of memory, you will not really get usable 4 gigabyte of memory, because the whole address space, although we have 2 to the power 32, we can't dedicate all the address bit to the memory. So we need to use some of the addresses to different other devices. So as such, we don't get all 4 GB of memory. So the usable memory could be always less than 4 GB. Okay guys, thank you very much for listening to me and see you in the next video.